Okay, so in this video tutorial we're going to look at one more example where we're going to learn how to go from conceptual design phase to the logical design involved in database design process. So quickly reminding ourselves that there are three important database design phases. The first one is where you gather all the requirements. The second phase is the conceptual design, where you present your requirements in form of you provide a formal description, basically using ER diagrams. In this course, we're gonna majorly focus on ER diagrams to represent our conceptual design, and then you take the conceptual design in the form of an ER diagram and write SQL or SQL code to develop the tables and populate them with data for the logical design phase. So these are the three phases that we always have to keep in mind when working with databases and their design process. We also learned in the previous video how to go from conceptual design to the logical design. Again, conceptual design gives you an ER diagram where you show how one table is related to the other and so on. But to be able to decide the structure of each individual table, we have to know how to go from ER diagram to the part where we actually can write SQL statements to create our tables. And we have these 6 steps that can help us do the same. These 6 steps give us few ideas that we can implement in the conceptual design phase to arrive to logical design phase. So I have these stored here, so I'm going to keep this on the left hand side of the screen and use the flight database example. And look at these 6 steps and see what we would get after performing each of these 6 steps. So if you haven't seen this before, this is an example adapted from our textbook. Highly recommend that you read the related text in the book. Here we have 4 strong entities: airplane, flight, passenger, booking. And then all of these strong entities have their attributes that describe their characteristics. For example, airplane has 3 characteristics, flight has 7, booking has none for now, and passenger also has 3. Again, reminding ourselves of the ER diagram notations. Underline tells us that this is the primary key for this table, this is the primary key for flight table, and this is the primary key for passenger table. Diamonds denote relationships, double diamond denote identifying relationships. These lines, they show partial participation, and double line shows full participation or total participation. So this is, you should be now comfortable in reading the ER notations given an ER diagram. So if you need more knowledge about that, please read the book. They go over each of these notations and when to use which notation in your ER diagram. So now focusing on this ER diagram, I'm going to go over these 6 steps on my left hand side one at a time and see how the ideas that I get from these 6 steps, or the outputs that I get from these 6 steps, how can they help me come up with my logical design for step 3 of the database design process. So let's start with A. Type the response here. So I'm going to type A. Now step A on the left hand side says that we need to locate strong entities first and then designate a primary key, add attributes as necessary. So what this means is, anytime there is a strong entity in your ER diagram, you should create a table for it in your database. So looking at this diagram, I can easily see that there's going to be at least 4 tables in my database: airplane, flight, booking, and passenger. So I'm going to quickly write those down here. Airplane, flight, passenger, and booking. Just a second line. Okay, so these are my 4 tables. So I've identified my strong entities, again reminding ourselves that strong entities are denoted by single rectangle, weak by double rectangle. So for airplane, let's also quickly write down the primary keys for each of these tables. So registration number is going to be the primary for airplane. For flight, we have flight number that uniquely identifies all the records in the flight table. For passenger, we have email address. This is on the assumption that one person has one email address associated to them and no 2 people have the same email address. And for booking, we don't have anything here, but let's assume that we have something called booking ID that can serve as the primary key for this table. Now when you start reading about this ER diagram in your book, you're gonna see initially the passenger was connected to the flight table with one diamond, which was books. So this was one to many relationship. So it was passenger, books, flight. Flights are booked by passengers. Many to many, that means many passengers can book many flights, and many flights can be booked by many passengers. But they broke it down to show us that there is a hidden entity called booking in between that relationship. So that's why instead of passenger and flight being connected by a single relationship, which is books, and connected by many to many, they broke that into 2 one-to-many relationships by adding this new entity called booking. So you could say a many to many relationship is basically a small number of, or a number of one-to-many relationships put together. So that's why this booking entity has been added. So now instead of many to many, we have 2 one-to-many's relationship between flight and passenger. So now we have identified our strong entities, we have identified their primary keys. We can add more attributes like it says here. So I'm not going to write them here, but I can quickly tell you what those could be. For airplane, the attributes would be basically everything except for the primary key, that is, we've already taken that. So now the other attributes that we must add to the table would be model number and capacity. For flight, you could add from, to, departure date, time, date, time. For passenger, you could again add their first name, last name. Email address is already taken, so we won't worry about that. And for booking, let's assume that booking has, since no attributes are shown here, we're going to assume that there's an attribute called booking ID that exists. Because think of the last time you booked a flight. Once you book a flight, hit submit button, make a payment, they send you a confirmation email consisting of a reservation or a booking ID. So that booking ID is what confirms your travel, and that's what I'm going to be using here. There may be more things in this table. For now, we're just assuming that there's something called booking ID that's going to identify this table uniquely. So that finishes step A. I'm going to move to part B now. It says in part B, for each weak entity, create a table and include primary keys of the owning table as foreign keys. Add attributes as necessary. Now, reminding ourselves how weak entities look like. Weak entities are anything that's surrounded by double rectangle. So as you can clearly see, there's nothing like that here. All the entities that are there, those 4 entities, are strong entities. So B is one step that essentially would not work in this example, so I'm going to write a not applicable next to it. So that also finishes this part right here. So moving on to step C, let's see what step C has to say. Step C says, for each one-to-one relationship, do all of this. So let's first identify how many one-to-one relationships we have, and then we'll worry about what's written next. So this is one-to-many relationship, so is this, and so is this. So 3 diamonds, that means there are 3 relationships in this ER diagram. All happen to be one-to-many, denoted by 1:n. So again, C would not be possible here since there is no one-to-one relationship. So I'm going to move on to step D. Step D says, for each non-identifying 1-to-n relationship, do all this. Now remind yourself about identifying and non-identifying relationships. Identifying relationships are denoted or represented by double diamonds. So since there are no double diamonds, that means all of these 3 relationships happen to be non-identifying. So that means yes, we may read this. We may continue reading this since this is definitely a thing of interest. And then it says, identify non-identifying relationship, and that also are 1-to-n type relationships. So we have 1-to-n relationship, non-identifying, 1-to-n, non-identifying, 1-to-n, non-identifying. So clearly we are interested in this step. So now this is slightly complex to read, but when I would present this pictorially, it would be very easy to understand what this step says. It says, anytime there is a non-identifying 1-to-n relationship, include the primary key of the entity on the one side as the foreign key in the table on the n side. So I'm going to expand this, highlight those 3 relationships, use pen. So this is one non-identifying 1-to-n relationship. What step D says, when you create a table for say flight, see, this is how flight may look like. I'm going to add a few columns. It says, take the primary key of the table that's on the one side. So this is the one side, and this is the n side. This is one side, this is n side. It says, take the primary key of the table on the one side and add it as a foreign key to the table on the n side. So that means when I'm developing the table for flight, I'm going to add registration number as a foreign key to this table. So let's start creating the table and adding fields. So I missed flight number. From flight number 2, depart date, depart time, arrival date, arrival time, and now registration number as a foreign key to this table. This is basically what step D says. Now you've seen one of these three 1-to-n non-identifying. Let's at least locate 2 more. See, option color. Okay, so this is another 1-to-n non-identifying. This is the third 1-to-n non-identifying relationship. So what it means is, say if we had our booking table, so far we assume we have booking ID, although there are no attributes to booking here if you look at the picture, but we assume booking ID would be one primary key. So here, looking at this one, the relationship between passenger and booking. It says when you're developing the table for booking, be sure to add the primary key of the table on the one side. This time the table on the one side of the relationship is passenger and its primary key is email. So I'm going to add email address as a foreign key in bookings table. Okay, and now let's look at this relation. This is the third one to and non-identifying. Again, when I'm developing the table for the end side of the relationship, which is booking table, I'm going to need to add the primary key of the table on the one side. The table on the one side, flight, its primary key, flight number. So my booking table would also have flight number as a foreign key. So my booking table has two foreign keys. One is email address coming from passenger table, and one is flight number coming from flights table. So this is step D. That finishes step D, since we've considered all the three relationships that we had. Now moving on to step E. Step E says for every M to N relationship. Now it's very clear that we do not have any many-to-many relationship here, so step E would not be applicable, so I'm gonna write an NA next to it. Let's see what we can do about the last step. The last step says for each relationship involving more than two entities, read carefully, for each relationship, that means you're looking for a diamond, involving more than two entities, rectangle. Let's look at our diamonds and rectangles. Diamond, it has two rectangles connected to it, two entities. This diamond has two entities, booking and flight. This diamond has two entities connected to it, that means two rectangles, two entities. Here the statement says for each relationship involving more than two entities. So clearly there's no relationship, looking at these three, there's no relationship in this example that has more than two entities involved. So F would also be not applicable. So now we have all these, we have gone through all these steps one at a time. We've gotten some idea what our tables are going to look like. So now is a good time when you can start coding and writing SQL statements like we have here, where you create table using proper SQL syntax, specifying what column goes, what columns go in a particular table, and then creating multiple tables of this sort. So this concludes our discussion on these 6 steps which help us design our database tables. So thank you for watching. I hope you learned something from this video. We'll talk more when we meet the next time in the class if you have any questions from this discussion right here. Okay, until next time.